Hello, and welcome to the NFPA LiNK YouTube channel. This page is dedicated to answering key questions you have related to electrical and life safety. With easy-to-use digital access to NFPA codes and standards, NFPA LiNK is your window to productivity. Today we've been asked to address electrically safe work condition requirements found in NFPA 70E, Standard for Electrical Safety in the Workplace. So from my dashboard and LiNK, I'm going to navigate to the 2024 edition of NFPA 70E. And if we open Chapter 1, we can move down to Article 110, General Requirements for Electrical Safety Related Work Practices. And immediately when we go into Article 110, we see this initial scope, but 110.2 goes directly into electrically safe work condition. So the initial requirement in 110.2a is that the employer establishes, documents, and implements an electrically safe work condition policy that does both of the following. So before we go on to the sub-items, let's just initially look at the base statement. So the employer has to create or establish a policy. It has to be documented, so it has to be written and available. But not only that, it also has to be implemented. It has to be used. So those are key things to extract out of that before we get into what it has to do. So it has to do both sub-items 1 and 2. 1 initially being that it requires hazard elimination to be the first priority in the implementation of safety-related work practices. So if we can eliminate the hazard altogether, there isn't an opportunity for the worker to get injured. So that should be first and foremost the most important thing. And I know out in the electrical industry that I worked in for many years, there's a little caveat that, people think if I put PPE on, it justifies me doing the work live. And that couldn't be the furthest from the truth. In another video, we'll probably go into the hierarchy of risk control methods, but just know that in those methods, the least effective way to work live is by utilizing PPE. So the policy has to be established, it has to be implemented, and when it's implemented, the initial point has to be that hazard elimination needs to be the first priority. Then we go on to sub-item 2 in 110.2a, and it says it has to comply with 110.2b. So if we go down into 110.2b, it requires energized electrical conductors and circuit parts that operate at voltages equal to or greater than 50 volts, so that's our threshold, shall be put in an electrically safe work condition before an employee performs work if any of the following conditions exist. So first, the employee is within the limited approach boundary, which is established. We can go into that in another video. But if they're working within that limited approach boundary, we need to be in an electrically safe work condition. Or if the employee interacts with equipment where conductors or circuit parts are not exposed, but still have an increased likelihood of injury from an exposure to an arc flash hazard. Okay, so those are the base statements. So 50 volts is the threshold if you're within the limited approach boundary, or if you're working in there where they're not exposed, but there's still an increased likelihood to an arc flash. Okay, now, there are exceptions to this rule, and those are listed in the exceptions to 110.2b. So if we move down into that, there's 5 different exceptions listed. Exception number 1 is when a normal operation of electrical equipment is permitted because the normal operating condition exists. Okay, so normal operating conditions exist when all of the following conditions are met. So these 7 items here all have to be met. If one isn't met, it's out. So it's not in a normal operating condition. So the only way it can be considered a normal operating condition is if the equipment has been properly installed, which likely is going to have a caveat of inspection based on meeting NEC requirements. The equipment is properly maintained, which is going to tie to NFPA 70B and also manufacturer's requirements around maintenance of equipment. The equipment is rated for the available fault current. The equipment is being used in accordance with the instructions included in the listing and labeling and in accordance with the manufacturer's instructions. The equipment doors are closed and secured, and that means All screws, everything that should be there, are in place. All equipment covers are in place and secured. And there is no evidence of impending failure. So that's one that we need to take into account, because there's a lot of equipment that gets walked up to, and you can just see by looking at it that it hasn't been maintained, and there's potential for impending failure based upon that. Maybe you're in an industrial establishment where there's chemicals or something of that nature that are coating the equipment. There's definitely different scenarios, but that's a caveat that we have to look at. Now, exception 2 goes into an energized disconnecting means or isolating element shall be permitted to be operated to achieve the electrically safe work condition or to return it back in place after an electrically safe work condition has been established. The equipment supplying the disconnect or isolating element shall not be required to be placed in an electrically safe work condition, provided that a risk assessment is performed and there's no unacceptable risk identified. So we're going to be turning the disconnect off in order to establish that electrically safe work condition, or we've already established that electrically safe work condition, done our work, and now we're engaging that equipment to be back live and running again. Exception number 3, energized work shall be permitted where the employer can demonstrate that the task to be performed is infeasible in a de-energized state due to equipment design or operational limitations. Now, these are kind of nice in 70E, because they give, under these specific exceptions, the next 2, they give you examples. So in the informational note, examples of work that might be performed within the limited approach boundary of exposed energized electrical conductors or circuit parts because of infeasibility to equipment design or operational limitations include diagnostics and testing. So that's a big one. If you're troubleshooting, if you're trying to figure out voltage that's going on or that isn't there, that's a big piece to this one where it needs to be utilized. Now, this doesn't alleviate you from using other mechanisms such as PPE to be safe while you're doing that. Certainly that's going to be required. But when it's infeasible based on the de-energized state to do what you need to do, this exception number 3 is here. Exception number 4 is where energized work is permitted where the employer can demonstrate that de-energizing would introduce an additional hazard or increased risk. Examples of this would be interruption of life support equipment. So if we're working in a hospital and there's a scenario where, if we turn power off to something, you're not going to, or you're going to pose a risk to the patients. Now, there's also a conversation that needs to be had around that when planning the work as to whether maybe the work that needs to be done, if it were to be done live or need to be done live because it would propose an additional risk to the patients. If it was done live and something went wrong, that would still pose the same risk to those patients, and you would still have likely a bigger problem in that case. So in that case, maybe it makes more sense to plan ahead for where the work needs to be done, try to relocate patients to a different area, and then be able to perform that work safely, de-energized, and then upon re-energizing that equipment, you can get the patients back into that area. So different conversation, different things that need to take place, but just that needs to be thought about when considering using this exception number 4. And then exception number 5 is when the equipment or the conductors or the circuit parts do not meet the 50 volt threshold. They're less than that, and there's no increased exposure to electrical burns or explosion due to arcs. So that's the overview of when an electrically safe work condition is required and when there are exceptions to that requirement. Within LiNK, we have this additional enhanced content. I wanted to point this out that this is in here because it gives lots of good information. Those exceptions we just went through, it breaks down. For example, here's the normal operating condition exception number 1, and it gives different examples, kind of how it works with all of the list items that were under that, 1 through 7, and then it goes into exception number 3, number 4, and then number 5. So it gives a lot more detail to all that criteria. And then the final piece here is there is a workflow chart. So if you hit this to download, it will download to your computer, and you can open up that specific workflow chart as a PDF and utilize that. for that. And it's obviously very similar to what you're seeing here on the page. So initially, is equipment within the conditions permitting normal operation? A yes or no. And you kind of take your path through there and what you need to do. And going through there, coming out with the results of either needing to establish an electrically safe work condition at the bottom left, or you can conduct justified energized work in accordance with 70E, which would mean energized work permit and all those type of things. So we hope this provided some insight into the electrically safe work condition requirements found in NFPA 70E. For more info on how NFPA LiNK gives you the knowledge you need to get the job done right, please visit www.nfpa.org/link.